Hello everyone. Today we will be doing some logarithmic equations, solve them, and check for any extraneous solution. So let's start with the do now problem. I hope you should give it a try first before looking at how I solve it. So let's go ahead and do it. Now here I have log of x squared plus 7x plus 12 negative log of x plus 4. So first of all, I can rewrite this as log of x squared plus 7x plus 12, and I can take this to the other side, so it will become positive log of x plus 4. Now you can see that I have log on both sides, so if I want I can remove the log. So I will have x squared plus 7x plus 12 is equal to x plus 4. Now I just remove x plus 4 from here, so I subtract x and 4 from both sides. Then I will get x squared plus 6x plus 8 equals 0. This is a quadratic equation, and I need to factorize it in order to solve for x. So I need to find two factors for 8 that should give me 8 when multiplied and plus 6 when I add them. Simply I have 4 and 2. So I can finalize this as x plus 2 and x plus 4. Okay. So now, if the product is 0, that means any of these factors is 0 will make the entire polynomial as 0. So x should be either negative 2 or negative 4. So, but before I finalize this solution, I should check if there is any extraneous solution. So if I have x as negative 2, so x is equal to negative 2, then x squared plus 7x plus 12, let's see. So I can write here x squared plus 7x plus 12 will become negative 2 squared plus 7 times negative 2 plus 12. So this is 4. 12 plus 4 is 16. 16 negative 14 is 2. So this is positive, and so this is a valid solution. And if I have x as negative 4, then x squared plus 7x plus 12, again I will replace x with negative 4 plus 7 times negative 4 plus 12. So I will have 16 plus 12, which is 28, negative 28. So this time I have a value of 0. Okay, remember, whenever we have a 0 value or a negative value, the log for that will be undefined. So we say that x is equal to negative 4 is an extraneous solution. And I can also say that x is equal to negative 2 is the only valid solution. Okay, so now you can see that in this problem we had this problem, and since there is a negative sign, we just took it to the other side, and then we removed the log, because if log of x is equal to log of y, that means x is equal to y. This is the property you can use. So once we got rid of the log from both sides, and we just x plus 4 got rid of it from here, so we ended up with x squared plus 6x plus 8. We changed that into a factored form, x plus 2 times x plus 4, and then we had two solutions. We checked for the validity of the two solutions. This was okay, and this was an extraneous solution. So we had to eliminate this option, and we say that in the end, x is equal to -4 is an extraneous solution, and x is equal to -2 is the only valid solution. So this is how you solve logarithmic equations. Now let's go over a couple of key points. The first point states for any positive values of x and y, if log base b of x is equal to log base b of y, then you can conclude x is equal to y and use that to solve. That's pretty much what you saw we did in this problem. The second point is if an equation has constant terms, rearrange to the form log of x equals c, apply the definition of a logarithm and solve. So we will see if we how we do this second point, how we apply it to the problem. But let's go further and do some examples from the teacher model. So for your convenience, I stated this property one more time. If log of x is equal to, if log x is equal to log y, then x is equal to y. Now let's do this first problem. So we have log of x squared equals log of 49. We can also rewrite this as log of x squared is equal to log of 7 squared. Okay, and then we can just get rid of the log. So x squared is equal to 7 squared, and when you take the square root, so x will be not only 7 but also -7. Now in any case, whenever we put x squared, then either it's +7 or -7. It in any case turns out to be +49. So both, we can say that both 7 and -7 are valid solutions. Okay, so this is our final answer for this part. Second problem, log of x plus 1 plus log of x plus 2 is equal to log of 7x -17. In this particular case, we combine these two. Give me a second. Okay, so now we again will combine these two. So we will have log of x plus 1 times x plus 2. We can write brackets here, is equal to log of 7x -17. Now again we have log on both sides, so we can remove the logs, and then x plus 1 times x plus 2 is equal to 7x -17. We multiply this x squared plus x plus 2x, that is plus 3x plus 2 is equal to 7x -17. We want to get rid of these from here, so we have -7x and plus 17, -7x plus 17. Okay, now we have x squared -4x plus 19 19 equals 0. Okay, so now 19, obviously we cannot solve it directly, so we'll use the quadratic formula. X equals -b plus or minus b squared -4ac square root upon 2a. So from this equation, we know that A is 1, B is -4, and C is 19. So we just plug those values here. Negative, -4, plus minus -4 squared, plus 4 times 1 times 19 divided by 2 times 1. Okay, negative and negative becomes positive, so 4 plus minus, this is 16, this is 76. So when you add 16 and 76, you will get 92. So I will write 92 upon 2. Okay, 92 is 4 times 23. So 23 times 4 is 92. So 4 can come out as 2. So plus minus 2 square root of 23 upon 2. Then we can simply write this as 2 plus minus square root of 23. So now this is my x, and if I just write it here, x is equal to 2 plus square root of 23 and 2 minus square root of 23. Now, when these are both positive, wherever I plug in, these are positive, this is positive, and this I need to check. So 7x means 7 times 2, 14, and then 7 times square root of 23. So 14 negative 17 is -3, and we'll still have a positive number. So this solution is valid. This solution, we again need to check. So this solution, if you put, if you want, I can do it here so that you can understand. So if we have 7x negative 17, and for x we have 7 times 2 negative square root of 23 negative 17, then we will have 14 negative 17 negative 7 times square root of 23. So this is going to be a negative number, -3, -7. And so log of -3, -7 square root of 23 is undefined. Okay, so I can say that this cannot be the valid solution. I will cross this solution off, and I say that x is equal to 2 plus square root of 23 is my valid solution. Okay, so this is how you solve the problem. Sometimes you have a quadratic equation that you cannot factorize directly, so you use the quadratic formula for that. Okay, now let's do the third problem. This time we have a negative sign here. So what we can do is we can take this to the other side. So if we add log of x negative 2 plus log of x negative 2, on both sides we will have log of x negative 4 plus log of x negative 2 is equal to 0. Then we combine these, so we'll have log of x negative 4 times x negative 2 is equal to, now this we can write as log of x, log of 1, so which is log of 10 power 0. Okay, so when we remove it, we will end up with x squared, -4x, -2x is -6x, -4 times -2 is +8, and that is going to be 1. So now we take this one over here. So x squared negative 6x plus 7 is equal to 0. Okay. Once again, now if you see factorize 7, 7 ones are 7, but 7 plus 1 will be 8, and plus 7 minus or negative 7 plus 1 will be negative 6, but it's going to be negative here. So you cannot factorize it directly. So here a is 1, b is negative 6, c is 7. So x is equal to, refer to this same formula, quadratic formula, negative b plus minus b squared negative 4ac square root over 2a. So we will have x equals negative 6 plus minus negative 6 squared negative 4 times 1 times 7 square root over 2 times 1. So this becomes positive, plus minus 36 minus 28, which is basically 8. So 6, we have 6 plus minus square root of 8 over 2. 8 comes out as 4 times 2, so 4 comes out as 2. So 6 plus minus 2 square root 2 over 2. And then we will have 3 plus minus square root of 2. Okay. So now we again need to check whether if any of these solutions is an extraneous solution or not. So what I'm going to do is I'm going to just use this space and I will say check. Okay. So when I have both positive, then I have x negative 4. So if I have x negative 4, then 3 plus square root 2 negative 4 is negative 1 plus square root 2, and that is square root 2 is 1.4. Square root 2 is greater than 1, so it's going to be positive. So this solution, the plus solution, is valid, and the negative solution is not valid. So at least for x negative 4, we can say, and x negative 2 is smaller.
Attention teachers, please pause to do a quick safety check. Check that students are properly wearing masks and ensure students are social distancing. Thank you.
So x negative 2 is less than x negative 4. If negative 4 is bigger, negative 2 is smaller, so it should satisfy the second one too. Now, if we have 3 negative square root 2, then negative 4, then we will have negative 1 negative square root 2, which is negative. So this is, in this case, this is undefined, and this is valid. So out of these two, we can say that, let me bring this to your view. So 3 plus square root of 2 is my only valid solution. So valid solution. I will write this like this. The other solution is an extraneous solution. That means this solution is not satisfying my equation. So with this, I'll just leave it here for a better view so that you can see. So we started off this way. So we had these two. We brought this thing to the other side, combined them together. 0 is basically log of 1, which is 10 exponent 0. When we removed the log from both sides, we had x negative 4 times x negative 2 equals 1. When we open it up, so we have x squared negative 6x plus 8. We get rid of this 1 from here by subtracting 1 from both sides. we ended up with this quadratic equation: x squared negative 6x plus 7 equals 0. Now we just use the quadratic formula, and we had a as 1, b as negative 6, and c as 7. So when we plugged in that and we further simplified, we ended up with these two roots: 3 plus square root of 2, 3 negative square root of 2. We just took one of the log values, x negative 4, and we checked. When we have 3 plus square root of 2, we have a value greater than 0, a positive value for the log. So that is valid. For the negative root 3 negative square root of 2, here we had a negative value. So that is undefined if you find the log of a negative number. So we had to say that this is our extraneous solution. So the only valid solution is 3 plus square root of 2. So this is how you do solve logarithmic equations. And I did some practice to show you how to do that. Now you will do the independent practice, okay? And there are a few problems just to make sure you understand things well. And I will give you a quick overview, not solve it. So when you start with this one, again, you already have log on both sides. You can get rid of the log. You only have some algebraic expression to simplify and solve for x. So x squared plus 1, x times x negative 2. You just solve it. Whatever x you get, you check if that value is a valid solution or not. Remember, if you have a log of 0 or log of a negative number, then you say this is not a valid solution, rather it is called an extraneous solution. Similarly, you have the second problem. You do just the same way I did the practice problems in teacher model. So you will combine these two. You will have log on both sides. You get rid of the log. Then just solve the polynomial for x. A few more problems here. Uh, so in the end, once you do a good practice, you should be able to finish it. For the second problem, uh, you have a log of some number as a value. Now you need to find out the actual number x, okay? So you need to use the table of logarithms. So a table of logarithm, you may have seen earlier, lists the value of log from 1 to 9. So you need to, without using the calculator to find out directly exactly the answer, you will use the table of logarithms. So then you will find the number, your answer, and similarly in this case. So with that, I will stop, and you can go ahead and start doing your work. Thank you so much.